Hello, everybody, and welcome to a new event organized by GoLab. We are very happy you could join us today. GoLab is a series of events dedicated to Go, the open source programming language developed by Google. It is a simple, efficient, and fast programming language. GoLab is organized by Develer, a company that develops hardware and software with industrial applications, with great focus on emerging and open source technologies. At Develer, we strongly believe in supporting training and collaboration, and because of this, we regularly organize technology events like conferences, workshops, courses, webinars dedicated to state-of-the-art technologies such as Go. Before we begin today's talk, I just have a few announcements. If you lose the connection, if the streaming stops for any reason, you can go back to the email that you received confirming the event and click on the link in that email. You will be brought back into the live room and you will be able to enjoy the rest of the talk. At the end of the talk, there will be a Q&A session where you will be able to ask all the questions that you want to the speaker. And for that, we have a special Q&A chat, which will be enabled only at the end of the talk. So we would ask you to wait to write your questions in this special chat, which is different from the regular chat that you have during the talk. And you can write them there, and we will read them to the speaker, and he will answer live. Finally, we would ask you to join our Discord channel to network and share ideas with like-minded people. You can click on the link above us to join us there. Today's talk is about building backends with Go. The speaker is André Eriksson, and we want to welcome André today with us. So that we can. Hello there.
Hey.
Welcome.
Thank you so much.
It sounds like you're in a very lively environment today.
Yeah, I'm dialing in from sunny Stockholm, where we have a bit of. I had to jump into a cafe, and you get to hear some of the party music from over here.
That's very inspiring, I have to say. Do you want to tell us something about yourself?
Yeah, so it's really great to be here. I'm André, longtime Go developer. I've been writing Go for 10 years. Now I'm doing a startup, which is what I'm here to talk about today, like what we're building and how you can use it. Before then, I was at Spotify for 8 years and did a lot of like the Go infrastructure for Spotify. So like building all the internal tooling and internal like libraries and frameworks and build systems and so on. So been using Go for a really long time, really big fan of the language, and it's great to be here with everybody.
Thank you. We are very happy, and we are very happy to have you here. So without further ado, let's jump into the talk, and we hope you will all enjoy it, and you will have questions for André at the end.
Yeah.
Enjoy the talk, everybody.
Hey everyone, really great to be here. I'm here to talk about distributed systems and a better way to build them. My name is André, and I'm the founder and CEO of a company called Encore, where we build a framework to make building backend systems way more productive and a lot more fun. So the backstory is that when you look at modern software applications, whether they're Instagram or Airbnb or Spotify or really anything else, B2B and B2C, it doesn't really matter. We're always trying to make them as simple as possible. And in many respects, modern software is richer, more reliable, and easier to use than ever before. But even though they're easy to use, they are in no way easy to build. In fact, building modern software is incredibly slow. So why is that? Well, if you take a look, especially on the backend side, building a distributed system involves incredible amounts of boilerplate. It involves hundreds, if not thousands, of moving parts. When I was at Spotify, we had several thousand backend services, and we had so many that we weren't exactly sure precisely how many, but we knew it was several thousand. And all of this combined means that building a backend application seems really simple on the surface, but there is incredible and overwhelming complexity lurking underneath. So when you're looking at a simple backend application, the requirements are often something like, we have our front end, it's going to send some data to our backend, and that backend is going to do some processing, whether it's, talking to another backend, calling an external API, storing some data in a database, fetching some data from a different database, and then sending it back to the front end. And if you repeat this over and over again for, 15 years, you end up building something like Spotify. It's all this just variations on the same simple pattern. But even though that sounds really simple, there's a lot more to it. Everything from build systems and deployment systems to secrets management and provisioning infrastructure to security and IAM, scaling, boilerplate, documentation, monitoring, and so on, and so on, and so on. The list is more or less endless. And what's so frustrating about this is that most of this work is actually not really to do with your application. They're just hoops you have to jump through to get your application into production. It's all undifferentiated work. And the real problem is that there is no one that will actually make this any easier. You have to do the work. And that's because, the cloud providers are really great, but they don't really understand how your application works. And the only one that really does is you. So you have to do the work. And that's really what Encore is designed to solve. It lets you focus on building your product and doing that in a way that enables Encore to automate and simplify all of these other aspects that we talked about that are undifferentiated and not really about your product. And what we're trying to do is we're really trying to solve and improve the end-to-end developer experience. So instead of looking at software development as a bunch of siloed tools that don't really understand each other, Encore is about being part of and improving the whole developer experience. So how you're writing code, to how you're collaborating with other people, to testing and reviewing, deploying and managing infrastructure in the cloud, to monitoring and debugging it when it's running. And then doing that feedback loop over and over again as quickly as possible. So how do we actually do that? Encore consists of 3 different parts. And on the first part, we have a framework. And that framework is designed to provide an incredible coding experience that is free of boilerplate and is just really easy and pleasant to build backends with. And when you use that framework, it enables us to do a lot of static analysis to better understand how your application fits together. And what we do with that is we create essentially a model or a graph of how your distributed system works. So everything from what backend services you have to the APIs, to when and where they're talking to other APIs, querying databases, using secrets, and so on. And the third part is a cloud platform that uses that understanding to do things like automating infrastructure and provisioning, and the third part is a cloud platform that uses that understanding to automate and provision infrastructure, automatically instrument your application with distributed tracing, and lots more. So together, what these really pieces do are to create a better way to build backends. So to summarize, it drastically reduces the boilerplate that you have to write to the point where 95% of your time is spent on writing business logic. It automates infrastructure setup. It manages secrets for you. It generates API documentation and provides built-in distributed tracing where you don't have to do anything to get this. And finally, it can even deploy all of this to your own cloud account so that you can use whatever cloud you want and still get a really, really fantastic developer experience. So with that, let's have a look at what this looks like in practice with a live demo. All right, so the first thing you have to do when you want to use Encore is create an application. So with that, we're going to Encore app create. Let's name it like this. And we're going to choose the Trello clone template. And let's cd into that. And what we've now done is we've created an application. It's been automatically linked to the Encore cloud platform. So let's open it up in Visual Studio Code and have a look. So here you can see that we have two different backend services. And we're going to take a look at them. But first, let's start the application. So the first time we do that, it will take a few seconds. It parses, compiles, sets up all of your different services and databases and everything. So now everything is running on our computer. So, oops. So what we're going to do is so usually when you look at a backend, it can be quite hard to understand what it's doing. So we're going to start by looking at a front end that I built just to make it easier to understand what's going on. So with that, we're going to go over to showcase.encore.dev. We're going to choose the Trello clone, and we're going to specify local development. And here you can see a very simple front end that is talking to the back end that's running on my computer. And here you can create boards, you can create columns, you can create cards, you can even drag them around. And if we refresh, they're still there because this is all stored in a database. So if we go back here, we can see that what I just did generated a bunch of API calls. And this is essentially what our backend is doing, right? So to take a look at what the code looks like, here is how you're writing code with Encore. So the first thing to note is there is a very, very little boilerplate here. To define an API, all you do is you create a regular Go function, and then you add this annotation, which is telling Encore to make this a public API. And Encore then analyzes all the code and figures out from the function signature what your API looks like. So here the input is the create params, and this is telling Encore that this API receives a name as its input, and the return type is a board which has these fields. So that's enough for Encore to understand what your API is doing in terms of request and response schemas. And then this backend service called board has a migrations folder where you can define migrations. And this is for creating a relational database. And here you can see that we've defined 2 different tables. And to actually use the database, all you have to do is you have to import the SQL DB package, and then you can just start querying. There's no need to do things like connect to the database or create or set up the database or migrate the database. You don't even need to handle a database password. All of this is handled by Encore for you so that you can just focus on building your application. Another cool thing about building with Encore is when you're defining multiple backend services and you want to make API calls between them, Encore makes that really easy. So this card package is actually a different backend service. And here you can see that we have a few different endpoints, but this list function is also an API. And this is actually an internal API that cannot be called from the outside. So when we want to call this from the board service, which is fine since it's also part of our Encore application, all we have to do is import this package and then call this as a regular Go function. And what's really powerful about this is that this makes the developer experience really, really great, because when you then import the package, you get auto completion on all of the endpoints. And you even get auto completion on the fields to call the API. So you can see here just how easy it is to work with API calls. And if instead of sending an integer, you pass in a string, you actually get a compile time error because Encore understands what your API is actually taking as input and output. And if you try to save this, you will see that Encore has live reload built in and will tell you when you're doing something you can't do. So if we turn this back, we will see that Encore then detects a change, successfully reparses and compiles and restarts your application. So that makes for a really, really great experience. So if we go back up here, we can see that another thing that Encore has is this developer dashboard. So we can open this up in our browser, and here we can see that you can really easily call your API straight from this dashboard. You can see the response here and so on. You can also click over to the API documentation. And here, Encore generates really, really high quality interactive documentation. You can even call it directly from here. You can see the inputs and the outputs for all of your APIs. And this is just done by analyzing the code. So this is always up to date and never incorrect because you just didn't remember to update the API documentation. It also does this thing, which is distributed tracing. And if you've never heard of just distributed tracing before, it's a way to really understand what a distributed system is doing. And normally, it's a lot of work to actually integrate and get it working. So most applications never do it. And the ones that do it only do it for production. But when you use Encore, all of this works out of the box and it works everywhere. for local development, testing environments, and production environments. And you don't have to do anything. So what we're seeing here is the board.get endpoint we looked at. It itself is calling to other endpoints. And on the right-hand side, you can see what each API call is doing in detail. So here you can see that the first thing we did is we did a database query. And if you want, you can even click on it to see where in the code base this happened. And then as soon as this is like a timeline. So as soon as this completes, we spawn 2 different Go routines to do 2 API calls in parallel with each other. So first the board.list columns, and then the car.list that we looked at. You can even see the requests and the responses of each API call. You can also dig into them more in detail if you want to see what they're doing. So here is what the car.list call is doing. You can see it's doing a database query and then returning the response from that. So this makes it really, really easy to find bugs as you're developing your application locally. And then once you're happy with your changes, all you have to do is to deploy them to the cloud is git push Encore. And you can see here that this immediately results in a deploy, where we are, parsing it, we're building, we're running all the tests, and as soon as this completes, it will actually trigger a deployment. Let's open this up. And now we're looking at Encore's cloud application. So once the tests complete, we'll provision the necessary infrastructure and then deploy this change to the cloud. And by default, Encore comes with a production environment that's hosted by Encore for convenience, but it's super, super easy to deploy it to your own cloud. So what you do is you create a new environment. You can say GCP. You would then choose GCP, and then you would connect your application. And this is just a few simple steps. And then once you've done that and you create it, when you then deploy, Encore will actually provision the necessary infrastructure in your own cloud account to run your application there. So once it's up and running, everything is green, then you can go over to the API section and we can call this. And as you can see, your application is up and running in the cloud. We can head over to the tracing section and we can take a look at the trace. So all of this works the same way for local development as well as in production. It works for test environments. It works for, we even have this thing called a preview environment, where if you link your Encore application to GitHub, Encore will actually create a dedicated environment for each and every pull request, and will automatically test and build every pull request, so you get immediate feedback. And then once you're using Encore for your front end, you can even generate a type-safe front-end client. So in this way, you can just say generate client for your app ID and then the name of the file. And then you'll get a type-safe client that you can easily use in your front-end. And it works like this. You create a client, you specify the environment, and then you can just call it. And you get auto-completion in the same way as before. And list. And there you have it. That is how easy it is to use Encore to build great backend applications. Okay, so now that we know how Encore works, it would be great to look under the hood and see how do we actually do all of this. And the first part is to actually parse and analyze the source code that you're writing to build up this graph that we talked about. And once you have that graph, we have a compiler that is doing a bunch of code generation and rewriting of the code to generate all the boilerplate that you would normally have to write. And finally, once we have that understanding and have generated all of this code, we can simplify your life in many different ways. So let's take a look at these one by one. So when it comes to the parser and static analysis, it's useful to start by understanding how a compiler works. So normally when you have a Go compiler or Go code, you can take a look here on the left where you have a very simple Go function. And there are essentially two main parts to a compiler. And the first is the parser. And what that means is we go from this code to more of a tree representation, what's called an abstract syntax tree. And that consists of nodes in a tree where each node has a different type. So here we start with that the root of the tree is a function literal, which has a list of statements in its body. And those statements are things like if statements that have a body, which has a return statement, and so on. We have expressions like a greater than or a So the first part to talk about is to take a look at. So the first step is the parser. And to understand how this works, it's useful to first look at a regular compiler. And in this case, we're looking at the Go compiler. And the way it works is there are essentially three steps to a compiler. We start with the Go code itself. And here we're looking at a very simple Go function. And the first step is to turn that into an abstract syntax tree. And what that tree looks like is essentially this. It's a bunch of nodes that are connected together that make up essentially the Go language constructs themselves. So you have things like function literals and if statements and binary expressions and return statements and so on. And once you have the abstract syntax tree, you take that and then the compiler turns that gradually into machine code with a bunch of different compiler passes that gradually lower it to lower and lower abstraction levels until you finally have machine code. And what I realized is that what we need for Encore is the same thing, but instead of Go concepts like function literals, we want distributed systems concepts like this. So what we're doing is we're creating a so-called Encore syntax tree where the nodes are things like backend services, databases, API endpoints, API calls, request and response schemas, and so on. And then what we can do with that is we can then compile that into lots of different things like an infrastructure description, API documentation, and so on. So how do we actually do this? So the first part is the static analysis step. And what we're doing here is we're parsing the source code using the Go AST package, which is part of the standard library. And once we have that, we then walk this tree to find things like the services and API definitions and so on. And once we have the API definitions with the function signature, we can then look at the type information and we can resolve all of the types to build up request and response schemas. And finally, once we've done this for the whole backend, we can then output a so-called EST application, which is part of the Encore project, which represents the complete application graph that we talked about earlier. And the next part is to turn this and really do code generation on top of it. And this is done in the Encore dev/Encore/compiler package. So how does that work? So the first step is to take the source code that you as an application author have written, and then use the Encore syntax tree to find all the places that we want to rewrite. And we then use a rope-like data structure, which essentially makes it really easy to cut a byte stream into smaller pieces and replace parts of it. And we use that to change function calls into, instead of calling the function, we generate a wrapper and we call that wrapper. And then we use the text template package from the standard library to generate wrapper code. And finally, we write the modified files that we've rewritten to a temporary directory. And then we use the go build command with the overlay flag to replace the generated files, or the regular files, with the ones that we generated. And this essentially tells the go command to swap them out with the modified files. So this is super convenient, and it was recently added in Go 1.16. So when we look at the third step, which is really the simplification part, there are many, many different aspects of how we simplify your development process. So we don't have time to go into all of them in detail, but I'm at least pointing out where they're located in the project. So we can generate API documentation, which you can find here. We do live reload. And what I think is really cool about this is that there is no downtime. It just works. And so we use the notify package to detect file system changes. And this works across all operating systems. And once we detect a file system change, we reparse and recompile the application. And if that's successful, we start up a new process. Once it's up and running, we switch the HTTP server over to route API calls to the new process, and then we kill off the old process. And this means that when you're using the built-in live reload, there is never a moment where the API is not working, because we do the switch over only when the new process is up and running. Another aspect that we do is we simplify secrets management. And the way this works is it's implemented in the secret package listed here. And it's pretty straightforward. So we fetch the secrets from the Encore's cloud platform, we cache them locally, and then once you run the application, we inject them on startup as an environment variable. And finally, perhaps most interesting, is the distributed tracing aspect. And this is a bit too complicated to describe in just a few seconds, but it essentially consists of three parts, where we first annotate, we add the tracing annotations at various points in the application when we're rewriting and generating the code. And then when the application is running, we have a local trace server that's receiving this trace metadata as your application is running and storing it locally. And the final part of the puzzle is this local development dashboard, where we're actually visualizing the tracing. And that's a combination of the trace metadata that we just talked about, and then combining that with the application graph to render it in a really compelling way. So to wrap things up, everything we've just talked about is completely open source. Check it out on github.com/encoredev/encore. If you think this is interesting, then by all means, start the repository, and we would love contributions with everything from filing issues for missing features or bugs, contributing with pull requests if you have something that you'd like to improve, writing documentation, or just giving feedback on the project overall. We really, really would appreciate to hear what you have to think. What do you think? And finally, even though I mentioned a couple open source projects that we use for this, I also want to mention that like everything we build these days, whether we realize it or not, is powered by mountains and mountains of open source. And we're essentially all standing on the giants of other open source projects. So to call out a few that we haven't really talked about in detail yet, the Go standard library, of course, it's really fantastic. Both the actual standard library as well as the extended standard library under golang.org/x. So things like the sync, tools, net, and crypto repositories are really, really great. tRPC and protobuf, really nice, really high quality. You've probably heard of, and many of you have probably used them already. And then 3 maybe smaller ones. So PGX is a really high quality Postgres library for doing everything from high level, like querying a database, down to really low level, like parsing the Postgres wire protocol and everything in between. Super, super high quality and powerful Postgres toolkit. The Gorilla WebSocket package, I keep coming back to this whenever I want to do streaming to a front end. It makes it really, really easy. And finally, the WireGuard package. I don't know if you've seen this, but WireGuard is a really, really powerful, lightweight VPN implementation that's pretty much taking over the world. It has a really high quality Go implementation that's very easy to use and works across all major operating systems. So with that, thank you so much. You can reach out to me on Twitter at _eandre. Do check out the Encore project on GitHub. And thank you so much to Developer for hosting this, and happy to take any questions, of course. Thank you.
Thank you, André, for a very interesting talk, and we would like to welcome you back with us so that maybe you can answer some questions that our audience will have for you. So welcome back, and let's see if is the Q&A chat open right now. It should be open, and you can ask questions in that Q&A chat. Okay, someone is sending you questions by email. All right, so first question. What was the motivation for building Encore?
Yeah, so this is I spent, and sorry for the background music, by the way, I hope it sets everybody in a good mood. It really comes down to, I was a backend engineer for many years and worked at Spotify, and I always felt that when you're building backends, you spend almost all of your time not really building your product, but really on managing infrastructure. And I felt like when you're just doing the same things over and over, that seems like quite a waste of time. And what I'm really passionate about is building products for our users. And so I was thinking about this for a really long time. What can we do to make that process easier, faster, and more enjoyable? And that's essentially what Encore is designed to be, is really to make building backend development much faster and much more enjoyable.
That is understandable. Thank you. And let's see if we have another question. So we have a question from Gladys Angelina. Why does return doesn't have 0 but some other value like -2? Maybe this is an example that you showed. And are other values allowed? And how does it work with other values?
I'm not quite sure what you're referring to, but I mean, you can, when you're defining APIs, you can certainly like adjust them as you see fit. There are a few constraints on how you do it, so you always have to return an error as the second or the second return type, and on the input you almost have to have a context as the first parameter. So those are like the requirements, but then how you structure the return value, it's entirely up to you. Like whether the type, if you want to have like integers or strings or whatever, you have complete freedom there. So I'm not really sure what the question is, but if you can like maybe clarify what you're referring to, I'm happy to give like a more specific answer.
Okay, so is Encore open source, and how can a developer contribute? You did say something about this at the end of your talk.
Yeah, exactly. So pretty much all we went through was like, how the open source project works, and I showed you some examples of like, I pointed at several parts of the code base where you can actually like take a look and understand how certain features are built. It's a bit hard to go into too many details during a presentation like this, but it's totally open source. You can use it completely for free. I just linked to the GitHub repository. We would obviously love contributions. I think since we open sourced it about 7 weeks ago, and we've had really great interest. So what we're doing right now is like assembling feedback from everybody who's trying it out, and putting together a list of like good starter tasks. Like if you want to contribute, here are a bunch of issues that anybody can pick up, and of course we'll happily help you along to make that even easier. So yeah, it's open sourced. There's the GitHub link, and would love contributions, of course. And if you are not sure how to tackle an issue, then by all means just reach out to us, and we will happily work with you on like helping you get started with contributing. Here's if you want to get in touch with us directly, I just linked to our Slack, which is maybe the easiest way to get in touch with us to collaborate.
Great. That's great. Okay, so we have like a continuation on the question before from Gladys Angelina that said, how do we assign the return which gives the output as a different value other than 0?
So it's really like any other, return value in Go, right? Like the first parameter, like when you're building an Encore API endpoint, is a data structure. So if you, for example, say that it's create a response, then you would just set the field in that variable or that object. So it would be something like create response success, or so something like this, where it's just like regular Go code in this regard. You define a type, and then you set the fields on that type when you're constructing it, and that is what Encore will then use to construct its response. For errors, it's a different thing, and then we have a package which I can link to. 1 second. This package, and that package has the functions for constructing things like error codes, if that's what you're referring to. So maybe that's more what you were thinking about. So it's the encore.dev/beta/errors package for those of you listening and not looking at the chat.
Thank you, André. The next question is about Encore and what was the hardest part to develop?
Yeah, so this is a great question. I think, like, I've been working on this for 3.5 years by now, and so there have been many, challenges along the way. What I think is the biggest innovation overall is really this like understanding of how a distributed system and your whole backend works. And so that was a lot of work to get the static analysis right and understanding all of this. But then once we had that in place, that was what we then used to do lots of things like, generate, provision all the infrastructure in the cloud, generate the API documentation and so on. But I think the part that was hardest was really the distributed tracing, because distributed tracing is really powerful. It's incredibly helpful for when you're it's both really helpful for debugging performance, but it's also, the way we built it with Encore, it's incredibly helpful for debugging locally, right? Most people don't have access to these sorts of tools for local development. But to actually build it required a lot of like low-level runtime work. So we are actually working with the Go runtime itself, and that was an entirely new type of challenge where we had to learn a lot of how the compiler works, how the runtime works, to make the distributed tracing that Encore provides like very, very high performance, to the point where today it's so performant that you don't really notice that it's there. And that I think is really nice, because it means that you can actually have it running all the time pretty much, because the performance, it doesn't really impact the performance of your application. And that's really where we want to be. So that was a really big challenge, but I'm really happy with the end result.
Very good. Let's see if we have anything else. Okay, so since gRPC was not, its use was not specifically mentioned in the talk, except for the open source library part, wanted to confirm, does Encore support a gRPC framework? And if yes, then does it provide auto-generated documentation for the same, since gRPC APIs have a different structure than REST? This is a several parts question, but I'm sure you understand.
Yeah. So the APIs you build with Encore, we do not today have like gRPC where you can expose them over gRPC. That's something that a lot of people have requested, and it's high up on our roadmap. So we're definitely going to do that. You can already today use Encore with gRPC for like if you want to call another API that is gRPC. So that part is totally supported. We're working on supporting it for the APIs you're building with Encore. And once we have that support, then it will work the same way as everything else. You will have generated API documentation that is really high quality and just works. You'll have the ability to generate like front-end clients for calling that API. Like all of this will work the same way as it already does. It will just also support gRPC. So that's the plan.
Thank you very much. Okay, so we have someone who thanks you for a great session, and we are all with him thanking you. Okay, so the question. On the on-screen demo, I saw only public cloud providers in the deploy screen. Is it possible to have custom targets configured for deployment other than the major public cloud providers? Is it possible to add support for something like a private cloud or on-premise infrastructure?
Yeah, so right now it's just the public clouds, but that's only because it was the easiest thing to target. We absolutely want to make it possible to deploy to your own infrastructure, on-premise. Like right now, when you deploy Encore to a cloud provider, we set up a Kubernetes cluster, and we use the managed service for running that Kubernetes cluster in a really easy way. But we absolutely want to support much more flexibility here, both so that you can say oh, I have a really small application. I don't need all the complexity of Kubernetes. I just want to run this on a single virtual machine somewhere. Or being able to say, here's a cluster of machines, but you can auto scale that up and down. But it will still be, like a private cloud or on-premise or whatever. So we're definitely working on much more flexibility there. Also, if you have your own internal Kubernetes cluster, it should be possible to use that. But right now, that's the public clouds are the only things we support, and it's not like the immediate thing we'll be working on because most people are using the public clouds. But it's definitely something we're actively looking at how to better add more flexibility in the deployment options, because I think the goal is not to force you to use the cloud. It's just that's where most people are.
So it is in the roadmap, basically.
Yeah, for sure. This is what we're really doing with Encore is let's get developers to not spend time on infrastructure and instead spend time on building their products. And that means that we want to take over the complexity of actually managing all of the infrastructure and so on. And we want to support all the different use cases that people have. And that definitely means, on-premise or private cloud. It's very much part of our roadmap.
Great. We are done with the questions for today. So we want to thank André very much for an interesting talk and a lively Q&A session. And for any other questions that you haven't had a chance to ask, you can join the Discord channel and you can talk about it there. So make sure that you are updated on our next event. And you can find a list of them up here, so you can find all the next events that we will have. And we thank you very much for being with us, and we are expecting you for our next talk. Bye-bye.